Hi all, welcome to i-tutor Academy. In today's session, we will start with the Unit 3, subsection 4 of MMPC 010, that is derivatives. The slope in mathematical use is concept of marginalism in economic use. Okay, so this if y is equal to y x and dy divided by dx stands for change in y as a result of one unit and change in x and marginal y of x. So the slope or marginal function has enormous use in a managerial economy. Okay, so this is about derivatives. So here is by dq divided by dp is equal to marginal demand of price when q is equal to q and close p. Okay, so like that. And in case of average, q by p is equal to average demand. And when marginal concept is divided by corresponding average concept, we get the measure of economic concept of elasticity, that is dq divided by dp into p divided by q, that is price elasticity of demand. Like that based on all equation. Other in you just refer your IGNOU study material also, so you will get more idea parallelly. And the such a elastic measures or the proportion of change. If the percentage change in demand is greater than the percentage change in price, then it will like that. Okay, so it's greater than 1 is elastic demand. So this is an example. So in block 2 there is elasticity is discussed, so we will discuss further there. Okay, so next one is partial derivatives. What is partial derivatives? In managerial economics, usually a function of several independent variable is encountered instead of a single variable, case shown above. Okay, so this is in single variable we discussed above. And for example, a consumer demand for a product depend on the price of the product, price of other related goods, income, taste, etc. When the price changes, the effect on quantity demand of the goods can be analyzed only when all other variables are kept constant. The functional relationship that is obtained between the quantity demand of a product and its own price is called a partial function. So a function of one variable when all other variables are kept constant. And the derivatives of the partial function are known as the partial derivative of the original function and is shown as like this. So this is the equation, and the conventional symbol used in maths for the partial derivatives is delta. And partial derivatives are function of all variable entering into the original function. So that is f of x. So here is an example. Please go through your IGNOU study material. You will get the equation, explanation, everything. And what is next is optimization concept. In optimization is the act of choosing the best alternative out of the available one, and it is described how decisions or choices among alternatives are taken or should be made. So all such optimization problem have three elements. One is decision variable and the objective function and the feasible set. In the decision variable, there are variables whose optimal value have to be determined, and in objective function it is a mathematical relationship between the choice variable and some variable whose value are to be maximized or minimized. The feasible set, the available set of alternatives, is called the feasible set. And a solution to an optimization problem is that set of value of the choice variable which is in the feasible set and which yield maximum or minimum of the objective function over the feasible set. An unconstrained optimization technique. For unconstrained optimization problem involving single independent variable, we need to satisfy some conditions, and in economics the necessary condition is called the equilibrium condition and sufficient condition is called the stability condition. And there may be equilibrium but it may not be stable. So the first order condition does not guarantee second order condition. Okay, so here in table the first order, second order optimization condition is there. Order is there in first column, condition, optimization, and unconstrained. And solution also here. Okay, so try to do it. And constraint optimization technique. There are many situations where the objectives function have to be maximized or minimized subject to certain constraint present in the problem. So there's a consumer may be maximizing utility subject to the income constraints. Okay, so example is here. And figure also here, objective functions. Okay, it's a graphical representation. And just go through your IGNOU study material, so you will get more idea. And based on this activity also here, okay, A, B, C, D. Okay, and answers also here, try to do it. And a regression analysis. What is regression analysis? A manager must often determine the total cost of producing various levels of output. The relationship between the total cost, that is C, and quantity Q is C is equal to A plus BQ plus CQ 2 plus DQ 3. Okay, so that is the equation for the C. And the value of the parameters are often obtained by using a technique called regression analysis. It determines the mathematical relationship between a dependent variable and one or more explanatory variable. And dependent variable, the variable whose variation is to be explained, and explanatory variable is the variable that are thought to cause the dependent variable to take on different values. And relation between sales and advertising expenditure, that is expense on advertising per month, that is cost. So diagrammatic graphical representation. And intercept parameter, the parameter that gives the value of y at the point where the regression line crosses the y axis. And slope parameter is the slope of the regression line b is equal to delta y divided by delta x, or the change in y associated with the 1 unit change in x. Okay, so activity 2 is here based on this data, and try to do it, so you will get more idea. So please refer your IGNOU study material, also parallel this video. And in between any doubts, you can contact us anytime. And for more MBA series, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA Complete Syllabus Coverage Classes for individual students, semester-wise subject with online flexible timing. For more details, contact on +91 623 827 1885.